Okay, the quadratic formula. Now the quadratic formula is used to solve for a variable, usually we call it x, but it could be any letter you want, when you are given an equation in this form. So you have the variable squared, you got a variable term, and you got a constant term, and they're all equal to 0. So if you're given something in this format, whether this is x or y or t or whatever, it doesn't matter, then you can solve for that one variable where a, b, and c are just numbers. They're coefficients, right? So they're regular numbers. So you can solve for x, because otherwise you can't solve for x in this particular format. Well, there's other ways, but we'll talk about that later. So the solution to this equation, solution means I'm now solving for x, is in this formula. This is the quadratic formula. Please note that 2a is actually the denominator for both parts. There's a lot of students who start going through this whole process and they put the 2a under here, or maybe they even stick it under the radical and it's not part of the radical, it's just under the radical, and they forget about the b being over 2a. So be careful of that. Also, note that there is a plus or minus here. This is read as plus or minus. So that means there's two solutions here. There's two answers that you're going to get. All right? So here are the steps that you need to follow. First of all, the equation has to be in this format. You got to have the x squared term, the x term, any constants, and then only 0 on the other side. If there's something else over here, move it. If there's x's over here, move them. Everything needs to be on the left except for the 0. Secondly, identify what is A, what is B, what is C, and make sure you include your signs. Is A a positive 2 or a negative 2? And we'll go through that. Then you're going to plug in your ABCs into this quadratic formula. And you're given the quadratic formula. B is B, B is B, A is A, C is C, and so forth. The 4 and the 2 never change and all that. After you plug it into the formula, you're going to go ahead and simplify the radical. Understand that you might have an I, imaginary term. In other words, if there's a negative under the square root, well, then you got to take the negative 1 out as an I. Next, you're going to combine all your like terms. Then you're going to simplify any fractions. For example, if you have 2 over 4, you need to simplify that into 1/2. So let's do several examples. All these examples are a little different, so keep watching all the way to the end. I know it's tough, but you can do it. So here we go. We have an ax squared plus bx plus c is equal to 0. So it's already in the right format. So my a is 8, my b is 2, and my c is negative 1. Here's my quadratic formula. So everywhere there's a b, I'm going to put a 2. And here's another b. Everywhere there's an a, I'm going to put an 8. And here's another a. Everywhere there's a c, I'm going to put a negative 1. Once I sub all these into the quadratic formula, it's simply a matter of taking each step slowly and carefully, paying attention to your signs, paying attention to your order of operations to simplify this. All right, so we got to get our exponents taken care of. I always keep this minus here and evaluate everything else so that I don't lose a minus somewhere. So that way all I'm thinking about is what is 4 times 8? 32. Times negative 1, negative 32. I don't have to remember if I've already used this minus or not. I just recopy it down and handle everything else. Well, now I know, oh, and 2 times 8 is 16. So 4 minus a negative is 4 plus. Then I simplify it. The square root of 36 happens to be 6. So I just put in a 6. Well, since this says plus or minus, I can say negative 2 plus 6 over 16, or negative 2 minus 6 over 16. They're both options. There's two answers, so I just separated into a positive and a negative since these are regular numbers. So negative 2 and 6 is 4, and then I simplify that fraction. Negative 2 and negative 6 is negative 8, and I simplify that fraction. So in this case, you got two numbers. Both answers are correct. X could be 1/4 or negative 1/2. Let's do another one. This one's different. Now the problem with this one is it's not in the right format. the x squared, the x, and the constant are not all equal to 0. We got to move this 4x. We got to move this 1. Everything's got to be moved over to one side so that it's equal to 0. If you start trying to pick a's and b's before it's moved, you're going to get the wrong answer. Once you get into this format, a is 2, b is -4, c is -1, boom. All you got to do is plug the a's and the b's and the c's in the right spots. All right. As you go through, remember you're going to simplify each part. I always keep the minus and then evaluate all this stuff, and then I can worry about if I have minuses or negatives, minus positives, whatever. All right, now I get down to here. 24 is not a perfect square, so I'm going to have to factor it out and try to find sets of 2. So I found a set of 2. I can pull that 2 out, and I'm left with the 6 underneath it. All right, so anytime you divide this and this by a number, I happen to notice that this is even, they're both even, so chances are they can be reduced. So 4 divided by 4 can be 1. I'm going to keep my plus or my minus. And 2 divided by 4 is 1/2, and I keep my square root of 6. This is my answer. All right, this one is going to have an imaginary solution. It's going to have a complex answer. So the first thing I need to do is rearrange to get my x squared, my x, and my constant all on the left-hand side. Since there was an x over here, I got to move it. Since it was being subtracted, I've got to add it. Once again, I identify what is my A, what is my B, what is my C, keep my signs with them, and I plug it into my quadratic formula. All right. Remember, this denominator is over both parts, so I keep it over both parts. Then I get down to this. The square root of a negative number has to be imaginary because there's nothing times nothing that's going to give you a negative number. So the -1 comes out as an I. I got to factor my 8. Oh, I found a pair of 2's, so my 2 can come out. My other 2 is left under the radical. I notice that all 3 of these are even, so I go ahead and divide the numerator and the denominator. You can think of this as like 4/6. So 4/6 is the same thing as 2/3, right? So that's what I did here. And 2/6 on this side is the same as 1/3, so I reduced this fraction as well, but I kept my I. All right, I'd like you to try one, and then we're going to do a few more. All right, here's this one worked out. It was already in the right format. I identified my A and my B and my C, plugged it into the equation. I have regular numbers down here. So since -8 can be plus 2 over 2 or -8 minus 2 over 2, I went ahead and separated that. So -8 plus 2 is here and -8 minus 2 is here. And then I just simplified that. Okay, let's try one that looks a little different. All right, here's this one all worked out. Hopefully it's the same as what you got. You had to rearrange the formula so that the x squared, x, and constant were all on the left-hand side. So you can correctly identify your A, B, and C with their signs. When you get down here, you don't have a perfect square, so you have to factor it out. Notice that these are even, so you can reduce them. All right, we're going to do one with an imaginary answer. There's an imaginary solution, but you can't just imagine the solution, you have to solve for it. All right, hopefully this is what you got. All right, best of luck.